Geometry, Quadrilaterals Review, Part 3, Problem 13, and possibly more than that. Let's see what we've got. Use rectangle MATH for the next two problems. MT equals 26, HA equals 8x minus 6, and HT equals 24. Well, we're going to have to find x. MT is 26, HA is 8x minus 6. We know that these two diagonals are congruent, so we can say 26 is equal to 8x minus 6. Add 6 to both sides. (32) is equal to 8x. 6 minus 6 is 0. Divide both sides by 8. 1x is equal to 32 divided by 8, which is equal to 4. HA has to equal 26 because MT is congruent to HA. They have given us this rectangle. SA is half of HA because the diagonals of a parallelogram bisect each other. SA is 1/2 of 26. That's equal to 13. What is the measure of MH? Well, for this, ST is also 13. The only equation I have used so far is 26 equals 8x minus 6. To find MH, I am going to have to use the Pythagorean theorem. A squared plus B squared equals C squared. A squared plus 24 squared equals 26 squared. Now wait. One of the special triangles is the 5, 12, 13 triangle. I see that 24 is 2 times 12. I see that 26 is 2 times 13. So I think that A is going to be 5 times 2. I think it's going to be 10. Why do I think so? Because a 5, 12, 13 is one of the special right triangles we studied earlier. I know I have right triangles because I have a rectangle. So let's just see whether I'm right. A squared is 10 squared plus 24 squared equals 26 squared. Is that true? 10 squared is 100. 24 squared is going to be 576. 26 squared is 676. This is a true statement. This guy is 10 units long. How convenient was that to recognize that we had a 5, 12, 13 multiple triangle. Okay, let's do one more problem in this section of the video. Let's look at problem 14. Okay. The measure of angle MAH is 3x plus 5. The measure of angle HAT is 4x plus 15. Now we know that we have a rectangle, and we have to have all kinds of measurements. What do we know for sure? We know for sure that this is a right angle. So my first equation is 3x plus 5 plus 4x plus 15 equals 90 degrees. Okay, what is that going to get me? Let's do some calculating. 3x plus 4x gives me 7x. I'm combining like terms. 5 plus 15 is 20 equals 90 degrees. Subtract 20 from each side. 7x equals 70. Divide both sides by 7. X equals 10 degrees. I bet we needed to find that out. X is equal to 10 degrees. The measure of angle MAH is 3 times 10 plus 5, 35. The measure of angle MAT, dude, we knew that at the beginning. That's 90 degrees. The measure of angle HAT is 4x plus 15. 4 times 10 is 40, plus 15 is 55. MTA MTA. What are we to do with MTA? MTA. What are we to do with MTA? Well, let's think about this for another minute. These guys are parallel. So we have alternate interior angles. Here's one parallel line. Here's another parallel line. Alternate sides of the transversal between the two parallel lines, alternate interior. So if we knew what this was, we could figure out what this is. And of course it seems obvious to me that these two must be congruent, but if we can't prove it, we can't do much about it. TSA, well, now wait a minute. Aha, look at this. AST is an isosceles triangle because the diagonals of a rectangle bisect each other. So if this angle is 55 degrees, this angle is 55 degrees. MTA, right? Because we have an isosceles triangle here. So now, how do we find the measure of TSA? 55 plus 55 is 110. The sum of three angles together is 180. 110 subtracted from 180 leaves me, well, this guy is 70. This is a linear pair. Angle S must be 110. It's also true that it is the exterior angle to my triangle. MTA 55 degrees, MSA 110 degrees, TSA 70 degrees. Sometimes you don't know what you know until you spend some time thinking about it. But look how we did that. Well done.